Alright, low budget films again here. So, did the first section. Those are the radiation safety Curie disintegration problems. We'll just call them that. Now, switching gears, going to a distance problem. A couple of things you need to know here. When dealing with Curies on your calculations prior, we're going to take those Curies now and convert them to Rankin's rims. Okay? Rankin, rad, and rim, like you guys already know, all the same thing, just different ways of measuring it. Rankin in air, rad in stuff, rim in people. So, no problems there. We're going to say we have iridium-192 here. If we had 1 Curie of iridium-192, that would convert to 5.2 Rankins per hour. Okay, and that's what that Curie stands for there. So, 1 Curie, iridium-192 gives us 5.2 Rankins per hour. 2 Curies be 10.4, 3 Curies, 15.6, so on and so forth. So, let's just for kicks and grins here say we got about 50 Curies, iridium-192. How many Rankin per hour? Okay, handy dandy calculator. 50 times 5.2 gives me about 260 Rankin per hour at 1 foot. Okay? That's what that stands for. So, that means if you just were given a value of 50 Curies and it said how many rim at 20 feet, you could convert this from 50 Curies, multiply that by our known value, 5.2 Rankins per hour per Curie. That's going to give us a value of 260 Rankins per hour at 1 foot. So, let's get rid of all of that. And back up. Cobalt's the same thing, except it's 14 Rankins per hour per Curie. Work the same exact way. If it was 50, you'd just take 50 times 14. Now, this guy over here, this inverse square law formula, you've already seen that in your book. That is a very, very important formula, and you guys are going to be using that many times over from here on out. So, if we had 50 Curies of iridium-192, and we wanted to know what the dose was going to be 10 feet back, here's what we'd do. We would take 50 Curies of iridium-192 times 5.2 Rankins per hour per Curie. That would give us that 260 again, I believe. Let me just make sure here. Yep, 260 Rankins per hour at 1 foot. And we want to know the dose at 10 feet. So, we plug our values into here. Okay, inverse square law. Double the distance, decrease the dose by a factor of 4. So we've got 260 Rankins per hour. Okay, that's intensity 1. We know that intensity. We're looking for intensity 2. We don't know that because that's where we're looking. This is inverse. This is distance 2 squared. This is distance 1 squared. So we're going to 10 feet. So that's going to be on top. Okay, that value is squared. And we have a known value right here at 1 foot. So it goes on the bottom, 1 foot squared, okay? 1 squared is itself, but that's not the point, okay? If this were 4 feet, you would put 4 squared, 5 feet, whatever, okay? No problem there. So we're going to take 260 times 1 squared. That ought to come out to about 260, I believe, since 1 squared is it itself, okay? So we did that. Now we're going to divide that by 10 squared. That's going to give us 2.6. So x here is going to equal 2.6. But let me draw that out or write that out how that happened. Okay? We had 260. Let me just write that so you can read it. 260 times 1 squared equals whatever. Okay? It's 260 in this instance. Okay? Divided by 10 squared equals. Okay? That's going to be our x value, or 2.6 Rankins per hour in this case, at 10 feet. So, you can see how that happened. 260 times 1 squared, okay, got that, equals 260, which we've got, divided by 10 squared, there is 2.6 Rankins per hour. Okay? Now, just as a side note, you already know this, but just as a side note, if you are trying to convert this from Rankin to millirankin, you would multiply this value by 1,000, okay, which you've already seen that. So that would be 2,600 MR at, that's actually MR per hour at 10 feet. Okay? Questions? I don't think you should have any questions, but let's just work this first one out for kicks and grins. I'm just going to write the numbers out here. We have 73 curies of iridium. Dose rate at 10 feet. Should have just changed the 50. Okay? Dose rate at 10 feet. So, 73 times 5.2, because we got to go from curies to Rankins, because the dose rate is in Rankin, Rad, or Rim. Okay, 73 times 5.2. $379.6. Good with all that? Okay. That puts us to Rankins per hour at 1 foot. So we're good there. So now we take, let's see here, just lost my train of thought. There it is. 379.6 over X, or intensity 2. Okay, we're going to 10 feet squared and we're at 1 foot squared. So 379.6 times 1 squared is going to be itself. So then we take that divided by 10 squared, gives us 3.796. So 379.6 times 1 squared equals, okay, 379.6 divided by 10 squared equals 3.796 Rankins per hour at 10 feet. That's how you work those out. And if it was cobalt, instead of multiplying by 5.2 here, like I said earlier, you just multiply by 14. So, questions there? You have email, you have all that access. Again, low budget films. So, here we go.